Could you rearrange this equation and find out what x really equals? What does x really equal if u equals x plus 3?
U minus 3.
X would be u minus 3.
No.
So now could you actually put in u minus 3 for that x value?
Yeah.
Can you just distribute the 1/2 exponent?
And now we could distribute u to the 1/2.
Like, could you do that at the beginning?
At the beginning?
Yeah, could you?
No, if you had rewritten this as x times x plus 3 to the 1/2, you cannot distribute when there is an exponent.
Well, yeah, I'm saying apply the exponent, and then.
Honestly, we're so.
That 1/2 cannot go inside of this. The only way to rewrite that is this.
But think about it. What if you do this? What if you do square root of x plus square root of 3?
That's mathematically illegal, incorrect, and wrong. Why can't you, Jordan? So what you're telling me, Jordan, is the square root of 1 plus 4 is the same thing as the square root of 1 plus the square root of 4.
Perhaps.
Perhaps, sure. The square root of 5 is equal to 3.
Maybe.
Yes.
No.
It's about the same. It's about the same.
Significant
If you
figures.
round up twice, 4 times.
That doesn't work. That's not,
For all
Use
practical
sig figs.
purposes.
it's wrong. For all practical purposes, it's
If
wrong.
you divide them both by infinity.
Alright.
So we're gonna approach this from a mathematically correct procedure, which would mean that you could now distribute that u to the 1/2 to this parentheses. Do you see the difference in these two situations? Yes. You cannot distribute that x to this parentheses, but you can distribute this single term to that parentheses. Now is this easy to integrate? Yeah, you just use your exponent rules. So this would end up being u to the 5/2 times 2/5 minus 3 u to the 3/2 times 2/3. Plus c. Okay, so we need to simplify this a little bit. So isn't this really 2/5 u to the 5/2 minus 2 u to the 3/2? Could you factor something out from each of those terms? U to the 3/2, and I'd like to take out a fraction. How can I change 2 over to a fraction with a denominator of 5?
2 over 2.
10 to the
2 over 2 is not a fraction with a denominator of
10 to
5.
the 5th.
How about 10/5?
That
Isn't
works.
10/5 going to give me the same value as 2?
Maybe.
So now, couldn't I factor out a 2/5 u to the 3/2? Yes, sir.
Would that affect your sleep? Or could you not do that because of the C?
This is just a constant.
Okay.
So really, we don't have to consider that. We can just put plus c at the end. Because you can factor out a 2/5 from your constant and still end up with a constant at the end. So I'm just going to bring that plus c down. So really, I'm just kind of separating it, and I'm going to put plus c at the end. Okay. When I factor out 2/5 u to the 3/2, what would this give me?
U.
Just u to the 1, yeah.
Minus
And then
5.
minus 5. Great. And now I just need to go back and change my u's over to what u really equals. U is x plus 3. So it would be 2/5 x plus 3 to the 3/2. And then x plus 3 minus 5, which you could then simplify. To x minus 2
And can we leave it like that?
plus c. Yes, sir, you can leave it like that.
So why couldn't you leave it at the first one that we found?
Or no, down a little, down a little.
Ms. Haber,
Aaron, can you move your head a little?
Yes, Lucas.
why can't you leave it at the 2/5 u to the 5/2 minus 10 minus 2 u to the 3/2 plus c?
It was a great
Because
shot.
that's a pretty complicated answer when you go back and put in your x's. And this is more simplified. This is just factored form instead of it being in that. They do have those common factors, so you would want to factor them out. And it's just simpler to do it with u's before you change them over to the x plus 3's.
Okay.
Okay, alright, let's look at another example. So you need to see another example very similar to the one we just did.
Not really.
If you feel okay with that, alright, we'll just roll it. Alright, any suggestions about our u value? It would work nice if we used u to be x plus 3. But then du is 1 dx, and then I've got all this extra stuff. Right? So right now, it looks like I would have 2x minus 1, because I'm not getting rid of that. Then couldn't I write this as u to the negative 1/2 and du? But I cannot leave that x there.
That'd be, u minus 3.
X is really u minus 3. So now you have to put that u minus 3 in here for x. So 2 times u minus 3 minus 1 u to the negative 1/2 du. So I would distribute and combine like terms. 2u minus 7 times u to the negative 1/2. Now will distributive property apply?
Yes.
Yes. So now it becomes the integral of,
2 u to 1.
yes,
Then minus 7 u to 1.
yes. Now this integrand should be pretty simple for us to integrate. So u to the 3/2 times 2/3. Yes, it would be 4/3. Good. U to the 1/2 times 2. So I need to find a common denominator of what I could factor out. What can you do with that 14? Change it to 42 over 3. Nice job. And then from each of these, I could factor out
4/3 u to the
u
1/2.
to the 1/2.
and a 2/3. Yep. So if I take out 2/3 u to the
Wouldn't it-
1/2, what?
Could you take out the 4/3?
Will 4 go into 42?
No.
No. So I can only take out 2/3.
Just have to be refreshed.
So this will be 2u minus 21. So I'm going to go back now and take what my u value was, which was x plus 3. You go ahead and just put it right here and distribute and combine those like terms. 2x plus 6 minus 21. Are you okay with that? Alright. Let's try one more example. So it is just a variation of u substitution, right? The issue that we're running into is, here we have more than just constants left over, right? We have that variable of x left over when I do my u substitution. So that's where you have to change those variables of x's over to u's, which is why this topic is called change of variables, because you're going to change your x's over to u's. We good? Peyton, you got what you need? Okay. All right, so let's look at example 3. Any suggestion about what our u should be? 2 minus x. du would be negative 1 dx. Do we have that negative 1?
Yeah, if we know that already, should we just go find the x, or should we just
Yeah.
find the x on one?
You wanna go ahead and find the x value, because you know you're gonna need to? There's nothing to take this out, so yes, you know you're gonna have to do that change of variable thing, that's fine. Do I have this factor of negative 1 though? So make sure that you're introducing it, negative 1 and negative 1. Okay, so what will our x,
Negative u plus 10.
yeah, I think I'm gonna write it as 2 minus u. Couldn't I do that?
Yeah.
2 minus u.
You could.
Okay, so remember this part is my dx, this negative 1 dx is my du. So that's taken care of. So I'm gonna have the integral of 2 minus u minus 1. And I still have this factor of negative 1 left over. Does it matter if I move that negative 1 from the denominator to the numerator? No, because it's the same value. Dividing by negative 1 is the same as multiplying by negative 1, so that's fine to do that. This is u to the 1/2, and this is du. Austin, you got a question?
Would it be 2 plus u?
Would it be 2 plus u? Let me work that out.
No, because it has to be
I would-
negative x taken out.
I would add the x to both sides, and then subtract u. So no, I still get 2 minus u. Is that what you were asking me about?
Yeah, just send out and it was still subtracting.
But you're okay with that now? That you see exactly why that is subtraction? I mean, you're just manipulating an equation, okay? So this would really turn into, what does that give you? Negative 1 plus u? Did y'all simplify that yet?
Mhm.
Wouldn't that turn into 1 minus u times the negative 1 out front? So negative 1 plus u times u to the 1/2 du?
Negative u to 1.
Yes, sir.
Add the u to 3.
Very nice.
You just plug it in.
Now we use our exponent rules. Now this time I've got to have a common denominator. What would the common denominator be when I've got thirds and fifths? 15ths. So I'm going to go ahead and change both of these over to 15ths.
10 15s.
Negative, correct?
Negative 15s.
Yes, and
6
very nice, 6 15ths. So what could you factor out from 10 15ths and 6 15ths?
2 15s.
2 15ths and u to the
3 halves.
3/2. Wouldn't that be negative 5?
Yeah.
Oh, yeah,
Plus
you got to put 15s.
3u. Do I need plus c in this problem? No, because it's a definite integral. Now, do you want to change these back over to x's
Yes.
and use 1 and 2? Okay, great, we'll do that then. 2 15ths. 2 minus x to the 3/2 times negative 5 plus 3 times 2 minus x. And I'm going to evaluate this at 2 and at 1. Do I really have to simplify it anymore since I'm getting ready to plug in values? I wouldn't spend any time simplifying anymore. Just plug in your 2 and your 1. So when I plug in 2 into this first expression, you're going to get 0, right? Because isn't this term 0 and all that multiplied together would be 0? Minus. Now when I plug in 1, it'll give me 2 15ths times 1 times negative 5 plus 3 times 1. That's negative 2. Times 2 15ths would be negative 4 15ths. And that negative out front turns your answer into a positive 4
Miss Hong.
15ths. Yes, sir.
Never mind.